Revolution Zero brings together the most bright and talented individuals across the UK to look at these old problems in a new way.
Okay, hi, I'm here at Innovation Zeros, and I saw a really interesting looking company called Space Forge. And I'm here with Neil. So Neil, what is Space Forge? Who are you, and are you really in space?
So I think you just described us as a sci-fi company, which is kind of indicative of the kind of stuff we're doing. So we're an in-space manufacturing company. So we make stuff in space, we bring it back to Earth, and then we sell it to people on Earth.
Just like asteroid mining in your favorite...
Way easier than that, because we don't have to go to an asteroid or anything like that. We send a free-flying satellite up into low Earth orbit, has a payload on board that does what we call chemical vapor deposition. So it turns gases into solids, and those solids are crystalline in nature, and they're materials that we would use for the semiconductor industry. And the semiconductor industry can then use that as a much more efficient, a much better quality material than would be made terrestrially in applications on Earth.
Hang on there, TSMC, Taiwanese semiconductor manufacturers. There's a new way. So you want to do this in space. What are the advantages of space?
So yeah, we wouldn't get involved in like the fab stage of stuff where you're like actually etching onto these wafers. It's just producing the raw material. We would sell it to somebody that would do the second part. So the advantage is really that in space there's nothing, right? On Earth, but honestly on Earth, everywhere you go there's stuff, right? There's ground, there's air, there's people, it's terrible. In space is the only place you can get away from all of that, and that gives you a really perfect manufacturing environment. So this payload in space can have free from the influence of gravity. So where we've got two gases that we want to combine together, on Earth they would separate because one is heavier than the other, and they would circulate due to convection currents. So that doesn't happen in space, and that means you can get a much better quality material, more regular crystal structure, we would say, as you grow this material in space.
Now we're at a carbon conference, roughly, right? Innovation Zero. Some people might be thinking, don't you need to burn a lot of fossil fuels to get to space? So what's the carbon angle here?
Yeah, I mean, actually, the carbon cost of flying into space is not that much higher than flying across the Atlantic. And it's really the massive benefits you get from this material. So a huge contributor to global emissions now is electronics generally, right? Whether that's electrified grids or whether it's sort of server farms running or telecommunications. So any impact you can have on the efficiency of those systems can have a huge global impact because it's a big piece of an enormous pie.
So move the emissions into space, maybe scope 4, scope 5, something like that for greenhouse gas accounting?
Actually, it's much more about can you reduce the emissions of those industries on Earth. So if you can let them do what they do more efficiently, effectively, let's say I've got an example in front of me on the table here, which is maybe not a perfect thing for a podcast, but basically I've got one very, very big chunk of metal, which is a heat sink, and that's normally used for cooling radio equipment, right? And we actually use one of these as part of our lab work. Now, that has to be powered, that has to take up physical space, it needs metals to be manufactured to make it. All of that is carbon cost. And if you go to like a 5G tower, they're really big and they're full of this kind of stuff. If you make the tiny, tiny bit of material that runs your power electronics in space instead of on Earth, that efficiency translates to something that is, I don't know how to describe that, size of a cake, but I'm a very sort of baked goods orientated person.
Maybe a 4-pack of beer. Yeah,
that's a better way of looking at it. We can shrink all of that down to something that's much smaller than a matchbox.
Okay. So on the table there's a big metal block and there's a much smaller green, looks like a big microchip from a cartoon maybe.
Yeah, and that's an actual back of the envelope calculation in terms of what savings can we make for size, weight and power. So a telecommunications provider, for example, would say, great, now we don't need anywhere near as much power to run our 5G tower. We can run it on less power, on a smaller footprint with less raw materials. That's all carbon saving. And it comes, yes, from having to do operations in space, but the result is massive. We actually, so back of the envelope calculation again, we save approximately 5 tons of CO2 for every 1 kilogram that we emit.
Interesting. So I got to ask, are you making stuff in space right now?
I would love to say yes, but we've got our first demo missions in the clean room, so we're all kind of itching, waiting for it to go into space. We've got some other projects running that will hopefully get us up a little bit quicker, but Forge Star 1, as it's called, is being assembled, getting ready for launch in the very near future.
Okay, so stay tuned for that. And what are you here at Innovation Zero for? What are you looking for? Do you need investors? Do you need partners? Do you need buyers?
Definitely looking kind of industrial partnerships. So we've got some great industrial partners already in BT and Northrop Grumman, looking at how we can actually apply our materials. But we know there are lots of applications for this, but we need to tell the supply chain now that these more advanced materials are going to become available, and they need to prepare for that in terms of device design, fab processes, all of that.
Okay, great. Well, I could talk a lot more, but I think that's enough for now. So thanks for taking the time, Neil. And anything else you want to share about Space Forge or space or your time at Innovation Zero?
Oh my God. Space is cool. Space is fun. It's a fun thing to work in because it's innovative, and companies like this that we're looking for ways of contributing to solving the climate problem and how we approach net zero means that you get to do something that is both technically very interesting and challenging, but also makes you feel like you're doing something worthwhile at the same time.
Are you hiring? What are you looking for in people you hire?
Yeah, we're hiring quite rapidly. We're a fast-growing startup. In fact, we're really a scale-up at this point. So yes, we're hiring. We have careers advertised as of today on spaceforge.com/careers. By all means, go and check it out.
Well done. What kind of skills are you looking for these types of jobs? Do you need to be a hardcore engineer?
No, we hire broadly. We take people in. Yes, we take people from engineering background. Might be space engineering, might be semiconductor physics stuff, chemistry. But we also take people at apprenticeship level as well. In fact, we actually have an apprenticeship being advertised right now. So non-university educated.
Love space, love climate. There's a company for you.
Exactly. Yeah, that's Space Forge.
Great. Thanks so much.